Let me talk about your graphs better. First one, if I'm taking the graph of your x is equals to your a into sine omega into t. So how do we get a graph beta? Can anyone tell me? If it is a sine graph, start from your origin like this. Something like this. So on your x-axis, we take displacement. On y-axis, we are taking the amplitude. A. So this will be your positive amplitude beta. So this will be equal to your plus A, and this will be equal to your minus A. Okay, the same way. If I'm writing the formula, V is equals to your A into your omega. V is equals to your A omega into your cos of your omega t. So for this one, what will be the graph beta? Velocity versus your time graph, isn't it? So if I'm talking about your velocity versus your time graph particulation, can anyone tell me how to write the graph with respect to this one? This is your displacement versus your time graph beta. This is a displacement versus your time graph. On x-axis, we are taking here right now the time. On y-axis, we are taking the amplitude. Here also velocity versus your time. As it is a cos function, so the graph will be something like this. So this will be the maximum amplitude and this will be your minimum amplitude. And third one, if I'm writing for your acceleration, what is an acceleration formula beta? A is equals to minus of omega square A into your sine of your omega into t. As it is negative, the graph will start with your negative particulation. This is acceleration versus your time graph. So the graph will start from the lower part like this. Okay. So here it will be your minus of omega square into your A, and here it will be equal to your plus of your omega square into your A. These are the three basic graphs which you need to remember. Bit. Clear? Clear, beta? Done? Sure. See this question better. Try to do this question once. See here. Find the displacement. Find the displacement of the particle when its velocity v is half of its maximum velocity. Can anyone try it better? Find the displacement of the particle when its velocity v is half of its maximum velocity. Please try it better. You can use the formula v is equals to omega under root of your a square minus of your x square. V is equals to how much? V max is how much beta? V max will be equal to your a into your omega. That means it is V max is equals to your half of your maximum. That is V max is equals to your a omega. So it is your omega under root of your a square minus of your x square. This omega will get cancelled. So if I am removing the root, it is a square divided by 4 is equals to a square minus x square. So therefore, x square will be equal to your a square minus of your a square divided by 4. So it is 1 minus 1 by 4. It will be equal to 3a square divided by 4 is your x square. So x will be equal to your plus or minus root 3 into your a divided by 2. So this will be the value of your x. Go through it once. Next one. Graph of velocity and your x. So let me draw the graph for this one. What is the relation with actually? What is my relation? V is equals to omega under root of your a square minus x square. I need to draw the graph between V and x. So I can write this one as V by omega is equals to under root of your a square minus x square. That means this can be written as of your V square divided by omega square is equals to your a square minus x square. So if I take x square inside, it is V square divided by omega square plus x square is equals to your a square. That means I can write this one as V square divided by a square omega square plus of your x square divided by your a square will be equal to 1. Okay. If your a square omega square is greater than, see here, right? If your a omega is greater than of your a, then we get a graph something like this, ellipse shape. Okay. This will be your plus a, this will be your minus a, this will be minus a omega, this will be your plus a omega. On y-axis, we take your velocity. On this one, we are taking in your x-axis. This will be the graph for that. Because we know that x square divided by a square plus of your y square divided by b square is equals to 1. This is your equation of your ellipse. Equation of your ellipse. So that is the reason this one. So if I'm taking the relation a omega is lesser than of your a, okay, in this term. Okay, so we'll be getting the graph between this is your x, this will be equal to v. So the graph will be something like this. Like this. This will be your plus a, this will be your minus a. This will be equal to minus a omega, this will be equal to your plus of your a. Clear? So depending upon your a value, that means if the a value is greater than b, then it will be vertical. If a value is lesser than of your b, then it will be your horizontal ellipse. Clear? Important graph. V square divided by a square omega square plus x square divided by a square will be equal to 1. You equate with your equation of your ellipse, that is your x square divided by a square plus y square divided by b square is equals to your 1. Okay, sure. Next one. Energy of your SHM. Energy of simple harmonic motion. Okay, so if I'm writing the energy of a simple harmonic motion, beta, first one is potential energy. First one is potential energy. You know the potential energy has been defined by the formula F is equals to minus of du divided by your dx. So if I differentiate and simplify it, we'll get the formula U is equals to half into k into your x square. Along with that one, some initial energy also, that will be equal to your U naught. U naught is nothing but of your reference beta. So U is equals to half of your k into x square plus of your U naught. Clear? K value, if I am writing the value, so U will be equal to your half of your k into x value will be equal to your a square into your sine square omega into t. So U minimum will be equal to 0 at your mean position. And potential energy will be maximum at extreme position, that is your half into k into your a square. When sine square value is 1, then maximum potential energy will be equal to your half of your k into your a square. Okay, so if I'm drawing the graph for this one, this one is on y-axis potential energy, on x-axis we take the amplitude. So the graph will be something like this, parabola in the upward direction. Okay, so this will be equal to your plus a, and here this will be equal to your minus a. Okay, and this one is at your mean position. At mean position, potential energy is 0, And this one is right now the potential energy part, that will be equal to how much? Half into K into your A square. Okay. Now if I'm writing the potential energy as a function of your time, potential energy as a function of your time, that means for this graph, it is a sine square graph, na beta. So how do you write the sine square graph? I'll draw with the other pen. So this will be equal to your very important graph. This is your T and this is your potential energy here, right? So sine square graph is something like this. Okay, so this one is your sine square graph. This one is sine square into your omega into T. So one time period, if I'm taking from here to here to here, right now it will be your one time period. From here to here, it is one oscillation, that is nothing but T by 2. And this one is your 3T by your 4, and this one will be 2, and this one will be your T by 4. So from here to here, this will be your one time period. Again, from here to here, this will be your one time period. Isn't it? So first half of this one will be T by 4, the next one is T by 2, 3T by 4, and it will be your T part deflection. Okay. So in this one, the important terms, what you need to remember is frequency. Frequency of your potential energy is double that of SH. Double that of SH. That means frequency of potential energy is equals to 2 times of your N. Okay, so I can write here average potential energy will be equal to 1 by 4 times of K into your A square plus of your U naught. So this will be your average potential energy basic formula. Potential energy is right now U naught is your reference beta. U naught is your reference. At reference potential energy, generally we take it as of your 0. These are two important graphs we need to remember for the potential energy. So potential energy formula is U is equals half into K into X square plus U naught. U naught is your reference. Okay, so it is minimum at mean position and maximum at your extreme position. Sine square graph, potential energy versus time graph is this one, and this is a potential energy versus your X graph. Next one is kinetic energy. Kinetic energy of your SH. We know the formula V is equals to omega under root of your A square minus of your X square. Isn't it? So we know the kinetic energy formula. What is the kinetic energy formula I can write here? So kinetic energy will be equal to your half into M into your V square. So that will be equal to your half into your M. It will be V is omega square into your A square minus of your X square. That means kinetic energy is maximum at your mean position. So it is your half into your M into your omega square into your A square. So at X is equals to 0. That is at mean position. At mean position, this will be the maximum kinetic energy. Okay. At extreme position, if I am writing, at extreme position, X will be equal to your A. Therefore, kinetic energy will be minimum. That will be equal to 0. Depending upon the value of your X, we can write the kinetic energy is maxima or minima. It is maxima at your mean position and 0 at your extreme position. Okay. We can even write the potential energy in terms of this one better. We know the formula. V is equals to your A omega into your cos of your omega into T. So kinetic energy will be equal to your half into M into your V square. A square omega square into cos square omega into T. So kinetic energy will become maxima when cos square value is equals to 1. It is half into M into your omega square into your A square. Okay, or else I can write this one as of your maximum kinetic energy will be equal to your half into your K into your A square. This is one more formula. So K is equals to how much for me? M into your omega square. Okay, so if I draw a graph for this one, kinetic energy, Tell me anyone, how can I draw the graph? This is your x-axis. On y-axis, if I'm taking the kinetic energy. So the graph will be parabola in the downward direction, somewhat like this. So here it will be your plus here, and here it will be your minus here. Okay, next one. If I'm drawing a graph of your kinetic energy versus time, kinetic energy versus time, this one, as it is a cos function, I can write this graph as right now something starting from your cos like this. This will be your cos function graph. So here the time period will be your t by 4, and here this will maximum at your t by 2. This will be your 3t by your 4, and this will be equal to your t. So one complete oscillation means you need to start from here, come from here to here. This is your half of the revolution. This is t by 2. Then from here to here, this is another half. This is your one time period of the oscillation. So frequency of this oscillation is again, frequency is your 2 times of your simple harmonic motion, and average kinetic energy will be equal to, average kinetic energy is 1 by 4 times of your maximum kinetic energy. Clear, Uda? So these are the two graphs we need to remember with respect to the potential energy and as well as of your kinetic energy. Very important relations, beta. Very, very important graphs also. We got the potential energy, parabola in the upward direction, and for the kinetic energy, parabola in the downward direction. So if I'm writing the total energy right now for this one, total energy. Can anyone tell me what is the total energy graph, beta? Total energy. Now add both of them. So total energy will be equal to your total energy will be sum of your potential energy plus of your kinetic energy. So let me write the potential energy and kinetic energy. Potential energy is equals to half into k into your x square plus potential energy is half into k into your a square minus of your x square. So total energy will be equal to 1 by 2 times of k into your a square. This is your total energy. Okay, so this is your constant. All of them are constant. That means if I'm drawing a graph, here if I'm taking the total energy and on the x-axis is your x, we get a constant like this. We get a constant like this. Okay, and this is your mean position, and this one is equals to your amplitude. So this one will be your plus A, and this will be your minus A. All three graphs, if I'm writing all three energies, if I'm writing, the graph will be something like this. So one I'll draw in the upward direction like this, and another graph in the downward direction like this, and another graph is parallel to this. So this one is your total energy, this one is your potential energy, this one is your kinetic energy. Done, better? This one is your mean position, this is your plus A, and this one is your minus A. Clear? Sure. So we got a total energy graph, potential energy graphs, a graph of your velocity versus x part deflation, and graphs of your x is equals to your a into sine, and velocity v is equals to your a into cos omega t, and acceleration a is equals to minus of your omega square into your a sine of your omega into t. Clear? Sure. concept of spring. This is also one of the important area where the problems are being based on the springs in your SHM beta. See here. If you extend a spring right now like this, if this is a spring and this is a block attached to this one. So when you are applying certain external force on this one, force due to the spring is directly proportional to displacement in opposite direction. So it will be equal to minus of your K into your X. K is your spring constant and X is your natural length width. X is your natural length. Okay. Now force due to your simple harmonic motion will be equal to minus of your K into your X. In this one, it will be your mean position. Okay. So as the acceleration is directly proportional to the displacement, SHM, I can write the time period T is equals to your 2 pi under root of your M by your K. Why? Because see, F is equals to your minus of your K into your X beta. F is equals to your M into your A, that is equals to minus of K into X. So acceleration is minus of K divided by your M into your X. Compare it with A is equals to minus of omega square into X. So therefore, omega square will be equal to how much beta? K by M. And omega will be equal to under root of your K by M. Omega is 2 pi by capital T is equals to under root of your K by M. So from this one, we are getting the time period T is equals to 2 pi under root of your M by K. M is the mass of the block and K is your spring constant. Spring constant and M is your mass of block. We are neglecting the mass of your spring beta. We are neglecting the mass of your spring. So time period will be T is equals to 2 pi under root of your M by Q. Mass of your oscillating body divided by K. I can write here T is also equal to your 2 pi divided by under root of your, this will be your mass of oscillating body. It may be even in SHM in water or something like that. Buoyancy concept also when you apply, you can use this concept. So T is equals to your 2 pi under root of your mass of your oscillating, any oscillating body divided by your K. Okay. Sure. Next one. Combination of your springs. Combination of your springs. First one is series combination. First one is your series combination. Let's see. There is one spring here and there is another spring here. Both of them are connected to a block of your mass of your M. And this one is fixed here. This is your K1 and this one is your K2. So this will be, when they are in the series combination, I'll be writing this one as 1 by K equivalent is equals to your 1 by K1 plus of your 1 by K2. For two springs, I can write K equivalent will be equal to your K1, K2 divided by your K1 plus of your K2. And time period will be equal to T is equals to 2 pi under root of your M by your K effective. That means that T will be equal to your 2 pi under root of your M by K effective will be equal to K1 into K2 divided by K1 plus of your K2. So this will be the time period. T is equals to your 2 pi under root of your M K1 plus K2 divided by K1 into your K2 particulation. The springs are in the parallel combination. No need of derivation of right now, that all better, that is of no use also right now. Just remember the application, that is more than enough. If two springs are in parallel combination, one above the other, so something like this, and this one is also something like this. This both of them are connected to a block of mass, say for example M, spring constant is K1 and spring constant is K2. Or even if the system is something like this. Here there is a spring and there is a block in middle of mass M, and even one more spring is been connected. This one is spring constant K2, this one is of your sin. This is also in the parallel combination, isn't it? Or else if the springs are connected like this, this is your block on quantum right now here M, and there is one spring connected to this one like this, and this one is one spring connected to this one. This is your K1 and this one is K2. All of this one are the parallel combination beta. So for this one, K equivalent will be equal to your K1 plus of your K2 plus so on like that one. So time period will become for me T is equals to 2 pi under root of your M by K effective. So it is your K1 plus of your K2. Frequency will be reciprocal of your time period. So that will be equal to 1 by 2 pi under root of your K1 plus of your K2 divided by your M. Okay, so you can just write the frequency with that given condition. So time period will be frequency will be equal to your frequency will be equal to reciprocal of your time period. Reciprocal of your time period. Unit will be equal to what beta? Hertz. So units of this one is equals to hertz. Like see if I'm giving you a small question for you. See here. There's one spring here right now. And there is one more spring right now here. There is one more spring right now here. And there is one more spring connected right now here. Okay. And all of this one are being connected to one more spring right now here. And there is a block of mass 2 here. Spring constant of this one is K, this one is K, this one is K, and this one is K. So K effective for the above part beta. All of them are parallel. So as they are in the parallel combination, so that will be equal to how much beta? K plus K plus K part, and that will be in the series combination with this one. So it is how much for me beta? If they are in the parallel combination, how much will be 1, 2, 3, 4? Isn't it? It will be your K by 4. Isn't it? So what will be the answer for this one? Can you tell me beta? This will be equal to how much for me? 4K. Isn't it? This total combination will be equal to 4K. Just let me take it. All of this one are in which combination beta? Parallel combination. That means K in parallel is how much for me? 4K. And this is also K. K in series is equals to. So I'll not write series. I'll write it as of your K. Okay. So K effective will be equal to 4K into K divided by 4K plus K. That will be equal to 4 into K square divided by 5K. This one and this one will get cancelled. So it is 4K divided by 5. So what will be the time period then beta? So time period will become for me T is equals to 2 pi under root of your M. M is right now 2M divided by K effective is 4K divided by 5. So that will be equal to 2 pi under root of 5 to is 10. So it is a 10M divided by 4 into your K. So still if I'm simplifying 2 mein jata 2 pi under root of your, so it is 5M divided by your 2K. This will be the answer. 2 2s are 2 5s. Clear beta? Sure. One more example like so. Tell me the answer firstly. There is one spring constant right now here. There is one spring constant right now here, and there is a block connected to this one is M, and there is one more spring right now here, and there is one more spring right now here. Isn't it? All of the spring constants are, say, for example, for me K. So T will be equal to how much beta? K effective, these two are in which combination beta? This is K, this is T, this is a parallel. So these are parallel, effective will become for me 2K. These are also one above the other. This were also in parallel, that will be equal to 2K. This 2K are also in the parallel. So that will be equal to your K effective will become for me your 4K. Time period will be T is equals to 2 pi under root of your M divided by your 4K. This will be the answer. Isn't it? See, ultimately when you draw it, you are getting one more spring right now. There is a block of mass M here and there is one more spring here. This one is how much? 2K. This one is also 2K. So obviously these two are in which combination? But a parallel combination. Done? Sure. Simple pendulum. simple pendulum. Okay. For simple pendulum, what will be the time period? But I already told you, t is equals to 2 pi under root of your. If I'm writing the answer for this one, if a bob is oscillating to and fro, this is your bob here right now, and here it is going right now, and here it is your another part, making an angle of your theta, and here also making an angle of your theta. So this is your angular SHM. So for your angular SHM, torque will be directly proportional to the displacement in opposite direction. Removing the proportionality constant, minus of c into your theta. So torque acting on that one is I into alpha in rotational mechanics minus c into theta. So alpha will be equal to your minus of c divided by your I into your theta. Okay. So here alpha is equals to, this will be equal to minus of omega square into your theta. This is your angular SHM standard formula, isn't it? So this is your angular SHM. So omega square is equal to how much if I'm comparing with this one? Omega square will be equal to c by your I. So omega will be equal to under root of your c by your I. Omega is equals to 2 pi by capital T, that is equals to under root of c divided by your I. So time period will become for me how much? 2 pi under root of your I divided by c. I is your moment of inertia and c is your torsional constant. Clear, beta? I is your moment of inertia for angular SHM and c is your torsional constant. Torsional constant. Clear? So if I'm writing the general equation, beta, therefore I can write here alpha is equals to minus of c by your I into your theta. Alpha value can I write in terms of displacement, beta? D square into theta divided by your dt square is equals to minus of c by your I into your theta. If I take this term here right now, this is d square into theta divided by your dt square plus c by your I into your theta will be equal to 0. So this is your differential equation of your angular SHM. Differential equation of angular SHM. So I can write here for simple pendulum, time period will be equal to your t is equals to your 2 pi under root of your L divided by your g. For simple pendulum, the time period will be t is equals to 2 pi under root of your L divided by g. So if I'm drawing a graph between t versus your L, what will be the graph, beta? Can anyone tell me? T versus of your L. So it will be parabola like this, isn't it? Because the t is, how it is proportional to this one, beta? T versus your L, it will be this one like this. If I'm writing the graph for the t versus your root t. So if I'm drawing the graph of t versus your root of your L, it will be a straight line parallel to the x-axis like this, making an angle of your theta. Okay, so we'll try to do the applications of this one in tomorrow's session, beta. Okay, and please try to revise the SHM from the starting and commit. So tomorrow we'll start doing the numericals based on that one. Tomorrow exclusively there will be a session on the numericals starting from the first topic to the topic which I have been told you in the today's session. Okay, take care, beta. Bye.